Alright, this is the current state of my code. I have made, I've done some relatively low-level networking stuff. I may not be rewriting TCP from scratch or anything, but I have two main files, program.py and client.py. This one acts like a server, and it creates a socket on port 9999, and then it waits and listens for some kind of response. And so you run server.py and then wait for someone to run client.py, and then client.py will take the IP address, and then the first time you run it, it will ask you to enter it, and when you type it in, it writes that to a file so that the next time you open it, you can just skip it and press enter. And you'll see if you just press enter, it'll load it from that file. And then because this is just running on my laptop and not a real server, the IPv4 address is dynamic, and you will need to update it regularly. But since I'm just testing this on my own laptop, I just get to not even deal with that and just use localhost. But I did get this to work on at least one person's other laptop earlier on in development, so this should still work perfectly fine if someone else is running client.py on a completely unrelated computer, as long as it's connected to the internet. And then, this is the tutorial I was following originally wrote this as a reverse shell that executes instructions on the terminal on the other person's computer. So I've thrown that code out and changed it with my own. So a lot of this is just right from the tutorial, but I at least did understand it well enough to know how to modify the code to turn it into something that isn't malware. Probably shouldn't have left that in the repository now that I think about it. I have this code, rsa.py, that is responsible. It basically acts as a library that these other two import. And then the program.py will call encrypt, and it will read the public key, which is the public key is stored here. You have the product of the two primes, which you modulate the message by once it's been converted to an integer. And then you have the other part of the public key, which is just the number 7. Now, of note, this the product of the two primes, the private key also needs to know this. So in a sense, the only unique part of the public key is just the number 7, which I just find amusing that doesn't leave it vulnerable. Well, actually, it does if you send a really small message. Shoot, I forgot about that part. I should have done some stuff to pad it. Oh well. I could also fix that by just making this like a slightly larger number, like I'm trying to think what's a good prime number. I think 129 might be prime. You usually want something like Wikipedia anyway said you want something with a low Hamming weight, which means most of the bits are 0 in the binary representation. Anyway, I've already spent too long talking about RSA. Wikipedia can explain that better than I can. For now, let's get to the actual demonstration. I have placed, so this has all kinds of stuff that I've used for testing. This is the messy version that has been cleaned up and stripped of most of this commented code, and has less silly variable names, and is, just in general, I'm actually proud of this version of the code. This one is very messy and silly, but it was so messy and so silly that I felt the need to clean this one in particular up. But here I've got just the necessary files. So the client side has client.py, the rsa.py that it uses at the library, the ip.text that it can log the IP address, messages.txt that it can log incoming messages, and of course the private key to decrypt incoming messages with, and then the server knows program.py, rsa.py. I didn't put that there. I don't know what that is. That's interesting. And the public key so that it can encrypt the messages. Which is a little bit funny that I'm the one who made the private key and I can't even use it. I have to give it to someone. I'll probably give it to my fiance, so that I can at least get some kind of use out of this thing. So I've navigated to those working directories. You can see server and client folders of this demonstration folder, and I can run Python program.py. You have to run this one first. I don't actually know why it breaks if you do them in the wrong order, but they just will. Oh, whoops. Python client.py. They just will miss each other if you don't do that. And I can use localhost because I'm just testing. And then I can type anything here. I can literally type anything, and that will send, and it'll say received. And it can be multiple words. This is a sentence with lots of words and symbols and numbers. And it says received. And then when you're done sending messages, you just type quit. And that will... Oh, right. It's because I changed it in here and not the copy that... that was a debugging thing. It was sending the wrong bytes. I put the... I changed the wrong line of code to include the .encrypt, so it wasn't encrypting anything except the quit message before. So that wasn't supposed to show up. But now I can just exit both of these independently. They're no longer connected. I just did a hand gesture and then realized you won't be able to see that. They're no longer connected together, but I can just type exit on both of those. And then I can go back into the client side and say messages.txt. And I probably should have turned some stuff on for debugging to prove that the RSA was working and that in transit it's just a sequence of bytes that even if you decoded that back into plain text, it would be gibberish and be full of control characters and stuff, and your text editor would want to puke. But you're just going to have to trust me that I tested this a lot, and I know that the RSA is working. I did download some software. I tried to generate my own keys in Python, but Python tapped out at somewhere between 20 and 30 bits. Industry standard right now is using like 2 2000-bit keys or 2000-bit primes. So I downloaded OpenSSL and used that to generate some prime numbers for me. And then from the prime numbers, I derived the keys. But so I can at least say it's as if if we were talking about physical keys, it's like I built the door and I forged the keys from the metal, but I bought the metal from the mine operator. I didn't mine the ore myself, but I still am pretty satisfied with. I've been wanting to do this for a long time, and I cannot tell you how satisfying it was when things started working. So I think that's it. Was there anything else on here? Yeah, okay. Use YouTube. So yeah, this was a lot of fun to work on, even though I did procrastinate it. It is if you haven't noticed the clock in the corner, now that I've drawn attention to it, I'm sure you have. Why is that? I'm not going to mess with that while it's running. Yeah, I hope I remembered everything.